Hello. My name is Sarah. Our group consists of 3 persons, me, Payne and Neelam. We will be presenting our business statistics capstone project entitled Prevention is Better Than Cure.
Let's start with Chapter 1. Introduction to our project.
Prevention is better than cure, is a proverb, which reveals that it's easier to stop something happening, in the first place, than to repair the damage after it has happened. It may saves us from inflicting any loss of relationship due to death, and saves us from economic loss. For this project we have decided to focus on 3 different areas that related to our theme. First is oil and gas industry, which will focus on oil pipeline condition, crude tower overhead. As of December 2017, there are 39 cases which involve almost $6 million loss to oil and gas industry. This occurred due to refinery department taking time to check the condition of the pipeline, by calculating the reading of element in sour water where the pipe is located that caused the pipe corroded. This topic will be discussed under Chapter 3 later on. The objectives are, to formulate the indicator and action to be taken as preset condition and to design and develop visualization for monitoring the oil pipeline condition. Second is accidental rate in Malaysia for Chapter 4, with more and more vehicles in the road over the years. Road accidents is also increasing at the same time and caused precious lives losses and monetary losses. There should be additional steps and analysis to be executed to reduce and prevent the fatal accidents. Hence the objectives of this study is aimed to find the relation and correlation from different factors of road accidents through statistical analysis. And topic for Chapter 5 is dengue issues in Malaysia perspective. Dengue vector control is the only effective way in controlling the outbreak. The increasing number of dengue cases reported in Malaysia is very threatening. Since actions taken once the case is reported, the chances of the outbreak to spread is high and the control action cannot be performed effectively. The idea of this project is to have a preventive action before some cases occurs. The objectives are, to implement data mining technique onto dengue and weather data parameter, and to provide analysis and prediction as guidelines for dengue outbreak. Spatiotemporal predictions are used in this study. The spatiotemporal scale used in this work was selected based on the distribution of the dengue data from 2010 to 2015. The chosen temporal scale was 1 month and the chosen spatial distribution was 1 state, Perak.
Moving on to Chapter 2, about our dataset.
For descriptive analytics, we are using cause of crude tower overhead pipe corrosion dataset, iron, chloride and pH. Data is captured daily, managed by refinery department, dataset for 2010. Meanwhile, data preparation required joining between 3 datasets using data's unique key. Data grouping to create indicator, and date formatting.
For statistical inference, the dataset is obtained from the annual report published by Ministry of Transport, as per the link showed in the slides. This annual report is aimed to provide comprehensive, readily available and up-to-date statistics on all modes of transport in Malaysia. In our study we only focus on land road transportation. For dataset preparation, the file in PDF format was first converted into a Word document using online conversion tool. After that all the relevant information were copied into Excel manually. Next, remove of unnecessary, duplicate rows and columns, and additional columns/rows have been added to perform aggregation. Subtotal and average columns have also been added to show the data in either vehicle type, year dimension. Lastly, we combined 2 of the table which is the subject of the study, number of casualty per year and also number of accidents for different vehicle type in each year.
For predictive analytics, we are using dataset of dengue cases which available at data.gov.my which provided by Mampu. Weather parameter dataset for Perak state is collected directly from Malaysian Meteorological Department. All the dengue cases for Perak state were provided in monthly interval. Thus, the other weather parameters are converted to monthly interval. The missing values for the weather temperature are pre-processed using imputation. In imputation, it substitutes missing values by computed from mid-average value.
Now I need your attention for Chapter 3 about descriptive analytics. Data preparation, which involve data cleansing, joining and creating formula, has been done in Alteryx. This is the overall picture of the workflow to get the final data source from all 3 raw datasets. The data is now being summarized in 3 condition of green, yellow, and red. Also alert response is created based on the chloride, pH and iron reading value. Next, the overall pipeline condition is determined by combination of condition in previous slide where 2 indicates worst condition, 0 indicates good condition and 1 indicates moderate condition. An interactive dashboard is created to display the results from the evaluation process by using Tableau. Tab 1, to show the overall condition of the pipeline. We are using tree map chart to visualize the condition on daily basis. Date filters are provided to assist the user and indicator legend to show the tab 2, to show the details of chloride, pH and iron value. This tab will shown once the user select the tree map chart in the first tab. Average line also provided to guide the user.
Moving to Chapter 4, Statistical Inference.
In this table we show the data that the statistical analysis will be conducted at. From here it is very difficult to identify any trend, useful information. However, it still shows the painful truth that there are around 6,000 plus lives were lost every year, and over 400 to 600,000 car accidents happen annually. It shows the impact and importance of immediate effort to reduce car accidents, especially fatal accidents. The statistical analysis is started by performing a correlation analysis using Excel. From here we can see that motorcycle has high correlation with the number of deaths per year, which align with the common impression. However, the surprise fact here is the accidents that involve lorry actually has negative and low correlation with the fatal accidents. This is opposite of what people usually think, and further analysis will be conducted to verify if the result of the correlation is valid. R has been selected to be used as the tool to perform linear regression analysis for the motorcycle. From the result obtained from R we can clearly see that R returns same correlation value as Excel. Multiple R squared is 0.5003, adjusted R squared is 0.4378, and the p-value obtained is 0.02215. The regression equation we obtained here is y equals 5088 plus 0.0142x. The analysis of motorcycle will be continued with 95% confidence interval analysis. For every additional 1,000 motorcycle accidents happened, there will be additional average of 2.6 to 25.67 cat.
Next we will continue linear regression analysis for the lorry. From the result obtained from R we can see that the multiple R square is 0.0222, adjusted R squared is minus 0.1, and the p-value obtained is 0.6811. The regression equation obtained is y equals 5088 plus 0.0142x. 95% confidence interval analysis. For every additional 1,000 motorcycle accidents happened, there will be a mean in between 23 lesser or 16 more casualties happened. This poor results does not bring any significant value.
Next is Chapter 5, Predictive Analytics.
This is descriptive analysis result. This analysis represents the distribution of each individual variables. Skewness is a measure of symmetry, or more precisely, the lack of symmetry. The skewness value can be positive or negative, or undefined. The correlation coefficient is a statistical measure that calculates the strength of the relationship between the relative movements of the two variables. The range of values for the correlation coefficient bounded by 1.0 on an absolute value basis or between -1.0 to 1.0. The correlation coefficient is a statistical measure that calculates the strength of the relationship between the relative movements of the two variables. The range of values for the correlation coefficient bounded by 1.0 on an absolute value basis or between -1.0 to 1.0. If the correlation coefficient is greater than 1.0 or less than -1.0, the correlation measurement is incorrect. A correlation of -1.0 shows a perfect negative correlation, while a correlation of 1.0 shows a perfect positive correlation. A correlation of 0.0 shows zero or no relationship between the movement of the two variables. The logistic regression coefficients, refer Table A, give the change in the log odds of the outcome for a 1-unit increase in the predictor variable. It can be summarized as, for example, every 1 unit change in max_temperature, the log odds of outbreak/fatality, versus no outbreak, increases by 0.9147.
Last but not least, Chapter 6, the conclusion for this project.
Describing descriptive analytics by visualization help the user to monitor the reading of sour water element effectively as the condition of reading is colored, which create alert to the operator. Conclusion of the statistical study: statistical analysis reflected that motorcycle accidents are more deadly compared to other vehicle types, and it aligns with general impression of people. Surprisingly, the accidents cases that involved lorry does not always related to deadly accidents, where the correlation between these two are weak, where R equals -0.149 compared to private vehicles such as motorcycle, cars, bus and taxi have significant lower case and lesser correlation with the casualties. Therefore, it suggested that in order to reduce the fatal accident, public transport is still the best option to go. By reducing the number of vehicles in the road, it helps to reduce the number of accidents as well. This preliminary analysis is done to predict dengue outbreak based on the weather variables. Historical dengue data and weather data to predict the occurrence. Based on the analysis provided, meteorological factors such as temperature and rainfall are proved to have a significantly associated with dengue outbreak cases.